Basically, when I look at these quizzes, the amount of times that I wrote wrong formula is a lot. So I just am reminding you the two formulas that you have to know on your own, the surface area formulas, and then reminding you which volume formula applies to which shape. Because I give you the volume formulas, but if you don't know where they apply, then it's not helpful. So we'll start it with volume. Volume of a prism. What is the formula for that? Area of the base times the height. So it looks like this, and then I would clarify what these letters stand for. That capital B stands for the area of the base. And this H stands for the height of the prism, but the height of the prism is not always up and down. The height of the prism is what pushes the bases apart. This is why you have two highlighters, or a couple highlighters actually. We're going to go through these shapes and just refresh our memory on the formulas. So let's talk about this first one. What kind of prism is it? Rectangular. So with a rectangular prism, you can make anything the base, but just for our sake, let's make the sides of the box the bases, just to prove a point. So go ahead and highlight the sides of the box. How would you find the area of a rectangle? Length times width. And then the height of the prism, this is where you want a second color. The height of the prism is what separates your two bases. So the way we highlighted it, the height would be what I highlighted in blue. It's how far apart your two bases are. If you want to just highlight one of them, it doesn't matter, but height is what pushes apart your two bases. In a second, you'll see why I said 3 would probably be optimal. Because the next shape, what kind of prism do we have? Triangular. So we're going to highlight the front. And to the best of your ability, highlight the back. What is the area formula for a triangle? 1/2 base times height. So remember that a base is always horizontal, a height is always, vertical. If it was a right triangle, remember that in a right triangle, the hypotenuse is never the base or the height. So keep that in mind. In a right triangle, hypotenuse is never base or the height. So the height of the prism is what makes this three-dimensional. So the height of the prism, you take a second color. I don't have a ton of room. But what I highlighted in green is the height of the prism, which is different than the height of the triangle itself. All right, the third shape, what kind of prism do we have? Trapezoid. Go ahead and highlight the bases. All right, and what is the area formula for a trapezoid? Area equals? Correct, times the height. What do we know about the two bases? They're parallel to each other. So when we're talking about this formula, we are only looking at the trapezoid itself. You're essentially ignoring the other part of the shape and just focusing on the trapezoid. The parallel sides will be your bases. I marked them with the little triangles. And then the height, this again represents the height of the trapezoid only. And it is, again, what pushes apart your two bases. So your height would look like this. But this height is different than the height of the prism that is in the prism formula. This is the height of the prism. So the height of the prism is what pushes apart your two trapezoids. All right, and then the last one is a cylinder. Is a cylinder technically a prism? No, but we can still use the formula. What is the area formula for a is pi r squared. You can mark where the radius is. What if I was given the diameter? How would I find the radius? Yeah, I would divide it by 2. Good. And then the height of the whole prism is, again, what pushes apart your 2 bases. So in this case, the height is up and down. So a pyramid, we don't go that much more into depth because we essentially just did that with a prism. But it's 1/3 area of the base times the height. The base is always across from the top vertex. But I'm telling you again, the number one thing that I see people do is not find the area of the base. The base is not a number, it's an area. You have to find the area and then plug that in. And then the height. So the height is from the very top to the very bottom. It could look like this, where it's got a right angle. They could also show it on the outside of the shape, like this. Which brings me to these two. So if you notice, I did these pictures twice because one of them is a right cone and one of them is a slanted cone. So remember that one of these requires the the actual height, and then one of them requires a slanted height. Since we're in the volume portion, a cone is a type of pyramid, so the height would be straight up and down. So if you want to mark that, height would be straight up and down. For a sphere, it is 4/3 pi r what? Cubed. Even though I gave the formulas, I still saw a lot of people doing squared. Remember that volume is cubed, and it's an easy way to remember that it's going to be cubed. So if they give you the radius, it's pretty easy. What if they gave you the diameter? You would half it. If they give you the circumference, let's say the circumference equaled, I don't know, what do I want to make it equal? What is it? 360 pi? That's big. Let's do 36 pi. What is the circumference formula? 2 pi r. Just 2 pi r. So what would I have to multiply by 2 pi to get 36 pi? Correct. You would do 18. So to show you the math way, the circumference is 36 pi, and it equals 2 pi r. You would divide by 2 pi. They're killing me next door. So the radius would be 18. So that's how she found that. Once you find the radius, you just plug it in and all that. So you'll see one with circumference. You'll see one with the radius like that. The last thing are the surface area formulas. You have to memorize these because I said rememorize, so take with that what you will. I won't give them to you. So how do you find the area of the bottom of a circle? How do you find the area? Pi r squared. And then you add it to the surface area of, the outer portion of the circle. So that's where pi r L comes in. What does L stand for? L is slant height. Slant height. So I'm going to highlight the slant height. Any of these could be the slant height. And since this one is also technically slanted, it is also a slant height. If this one were straight up and down, which it's not, if it were like where it made a right angle, that would not be a right cone. Like, I don't know if my picture does it justice. If it was slanted, so still slanted, but made like a right angle with the ground, this is not technically a right cone. Because the vertex of the cone, which is this top point, needs to be above the center. This would still be slanted, but if this were a perfectly vertical line, this would be the slant height. But I think that both of these are slanted on this one. So that's why either of them could be the slant height. All right, and then the volume of a sphere, we're doing surface area. Surface area of the sphere is 4 pi r squared. And that's it. 4 by r squared.